Welcome to Hydrohaven Garden Enthusiasts. Today we're diving deep into one of the most transformative yet misunderstood aspects of gardening success, building humus-rich soil. If you've struggled with plants that just won't thrive despite following all the conventional advice, the missing piece might be humus, the stable, complex organic matter that serves as the very foundation of living soil. Unlike raw organic material that quickly decomposes, true humus represents the pinnacle of soil development. It's a dark, spongy, complex substance created through years of biological activity that dramatically improves everything from water retention to nutrient availability. Many gardeners mistakenly believe they're building humus when they're merely adding organic material. But today, I'll show you 6 proven methods to genuinely increase stable humus in your garden soil based on both ancient wisdom and cutting-edge soil science. What exactly is humus, and why does it matter? Before jumping into methods, let's clarify what we're actually building. Humus isn't simply decomposed organic matter, it's the stable end result of complete decomposition, resistant to further breakdown. Think of compost as the teenager and humus as the wise elder of soil organic matter. While compost might last a season or two, humus persists for decades, sometimes centuries. This stable carbon-rich material transforms your soil in remarkable ways. It creates ideal soil structure by binding clay particles into aggregates while simultaneously giving body to sandy soils. Humus acts like a sponge, holding up to 90% of its weight in water, yet maintaining perfect aeration. Perhaps most impressively, it serves as an ion exchange system more effective than any fertilizer, making nutrients available precisely when plants need them rather than leaching away with rainfall. Modern agriculture has depleted humus levels dramatically, with some studies suggesting we've lost 50 to 70% of the original humus content in cultivated soils worldwide. Reversing this trend in your garden not only produces phenomenal plants but contributes to carbon sequestration and climate resilience. Now let's explore how to build this black gold in your own garden. Method 1. Strategic sheet mulching. Sheet mulching stands as one of the most effective ways to build humus when done correctly. This isn't simply throwing down a layer of cardboard and wood chips. Strategic sheet mulching mimics the natural forest floor layering process while accelerating humus formation. Start by laying down nitrogen-rich materials like fresh grass clippings or aged manure directly on the soil surface. This thin layer provides the nitrogen necessary for decomposer organisms to break down carbon-rich materials. Next, apply a layer of corrugated cardboard or several sheets of newspaper, overlapping edges by at least 6 inches to prevent weeds from finding gaps. Now comes the critical phase that transforms ordinary sheet mulching into a humus-building powerhouse. Create alternating thin layers of high carbon and high nitrogen materials. Carbon-rich materials include fall leaves, straw, or wood chips. Nitrogen-rich materials include coffee grounds, grass clippings, or manure. The final layer should be 3 to 4 inches of partially decomposed compost or aged wood chips. This protects the layers beneath while providing habitat for earthworms and other soil organisms that will incorporate the developing humus into your topsoil. Water this entire multi-layer system thoroughly and allow it to develop for at least 6 months before planting directly into it. What makes this approach particularly effective is the layering pattern that creates diverse decomposition zones, allowing different organisms to transform organic matter into increasingly stable forms. The gradual breakdown process incorporates these materials with existing soil minerals, creating true humus rather than just compost. Method 2. Native microorganism cultivation. Indigenous microorganisms form the workforce that transforms organic matter into humus, yet many garden practices inadvertently reduce their populations. This method focuses on deliberately cultivating these beneficial native microbes to accelerate humus formation. Begin by creating an indigenous microorganism collection from healthy local forest soil. Find an undisturbed forest area and collect about 2 cups of soil from just below the leaf litter where decomposition is actively occurring. This soil contains microbes perfectly adapted to your local climate and conditions. Create a microbe incubation mixture by combining this forest soil with 1 cup of cooked white rice, cooled, and 2 tablespoons of molasses in a breathable container like a wooden box or unglazed clay pot. Cover with breathable material like cheesecloth and store in a warm, dark location for 7 to 14 days. When the rice is covered with white, yellow, and possibly pink molds, avoiding any blue or green molds which indicate contamination, you've successfully cultivated your native microbe population. This cultured mixture becomes your microorganism starter. Next, create an activation solution by mixing 1 part of your microbe starter with 1 part molasses and 20 parts non-chlorinated water. Allow this solution to ferment for 7 days in a container with an airlock or loose lid to release gases. The finished liquid contains billions of beneficial microorganisms specifically adapted to break down organic matter in your local conditions. Apply this solution to your garden at a rate of 1 cup per gallon of water as a soil drench monthly during the growing season. These microorganisms dramatically accelerate the conversion of organic matter into stable humus complexes while improving plant health through numerous symbiotic relationships. This method works because it reintroduces the full spectrum of decomposer organisms often missing from disturbed garden soils. These organisms process organic material through multiple stages, eventually creating the complex polymers characteristic of true humus. Method 3. Biochar Integration System. Biochar represents one of the most exciting developments in sustainable agriculture, inspired by the ancient Amazonian terra preta soils that remain fertile after thousands of years. Unlike ordinary charcoal, properly made biochar provides the perfect habitat for microorganisms, while stabilizing carbon in a form that can persist in soil for centuries. Creating effective biochar begins with pyrolysis, heating woody material in a low-oxygen environment. While specialized equipment yields the best results, you can create small batches using a simple retort system. Fill a metal container with hardwood chips or stalks, create a small hole in the lid, and place this container inside a larger fire. The inner material will convert to char without fully burning to ash. The critical step many gardeners miss comes next. Raw biochar actually reduces soil fertility initially as it absorbs nutrients. Charging your biochar transforms it into a humus-building powerhouse. Soak freshly made biochar in a mixture of compost tea, worm castings, and a small amount of fish emulsion for at least 2 weeks before soil application. This charging process fills the microscopic pores with nutrients and beneficial microbes. Incorporate charged biochar into your soil at approximately 10% by volume, working it into the top 6 inches. The stable carbon structure of biochar creates perfect habitat for humus-forming microorganisms, while itself persisting for hundreds or even thousands of years. The charged biochar immediately improves soil structure while gradually contributing to stable humus formation through microbial activity on its surface. What makes biochar particularly valuable for humus development is its recalcitrant carbon structure that resists decomposition while providing protected microsites where humic substances can form and accumulate without being consumed by other soil organisms. This creates a long-term foundation for continuous humus development. Method 4. Deep-rooted cover crop rotation. While surface applications of organic matter contribute to humus, some of the most effective humus building occurs deeper in the soil profile through specialized cover crop management. This method utilizes specific plant combinations to build humus throughout the soil profile rather than just the surface. Implement a cover crop rotation focusing on plants with deep, extensive root systems. The ideal rotation includes a diverse mix of plant families, deep tap-rooted plants like daikon radish or comfrey that break up compaction, fibrous rooted grasses like cereal rye that create extensive soil aggregation, and legumes like crimson clover that fix nitrogen to feed soil life. Plant these cover crops densely and allow them to reach maximum root development, usually just before flowering stage. Instead of removing the plants, use the chop and drop method, cutting stems at soil level and leaving both roots and tops in place. The above-ground portion provides mulch while the root systems decompose in place, building humus precisely where it's needed throughout the soil profile. The magic happens below ground as the dying roots release exudates that feed soil microbes, creating a burst of biological activity. As these roots decompose, they create channels lined with carbon-rich materials and microbial colonies. Over successive rotations, these root channels develop into stable humus pathways, extending deep into the soil profile. For maximum humus development, implement this rotation for at least 3 full cycles before returning an area to production. During production seasons, continue using living mulches between crop rows to maintain continuous living roots in the soil. This method works because it mimics natural prairie systems where underground biomass often exceeds above-ground growth, creating some of the most humus-rich soils on Earth. Method 5. Fungal dominant woodchip pathways. Many gardeners underestimate the role of fungi in creating stable humus compounds. This method leverages fungal decomposition pathways to create some of the most stable forms of humus through a specialized woodchip management system. Create permanent garden pathways using freshly chipped hardwood or ramial, which means small branch wood chips at least 4 inches deep. Fresh chips are preferable to aged ones because they still contain the sugars and nutrients that feed fungal populations. Initially, these fresh chips will actually consume nitrogen as they begin decomposing. To prevent nitrogen robbing from adjacent soil, spray the newly laid chips with a mixture of 5% agricultural molasses diluted in water. This provides ready energy for decomposers without depleting soil nitrogen. Within a few months, white fungal mycelium will begin appearing throughout the wood chips. This indicates the fungal decomposition pathway is established. At this stage, lightly dust the pathway with worm castings or compost to introduce humus-forming microorganisms that work synergistically with the fungi. Over 2 to 3 years, the bottom layer of these wood chip pathways transforms into dark, rich humus with exceptional stability. Each season simply add 1 inch of fresh chips to the top of the pathways to maintain depth while continuing the humus building process below. Periodically harvest humus from the bottom layer of well-aged pathways and incorporate it into growing beds. This method works because fungal decomposition produces more complex carbon compounds than bacterial decomposition. The lignin in wood chips transforms through fungal processes into humic acids and humans, the most stable forms of humus that can persist in soil for centuries. Method 6. Vermicompost Integration System. Worm composting produces some of the richest organic matter available to gardeners, but few realize that strategic use of vermicompost can dramatically accelerate humus formation in garden soils through a specialized integration approach. Traditional application methods scatter vermicompost throughout the soil, but the concentrated interface method creates distinct zones where vermicompost meets mineral soil, maximizing humus development. Create narrow trenches about 6 inches deep between plant rows or around perennial plants. Fill these trenches with a mixture of 40% finished vermicompost and 60% partially decomposed leaf mold or aged compost. Cover this mixture with a thin layer of soil, then apply 3 inches of mulch over the entire area. The covered trench creates an ideal interface zone where vermicompost's microbial populations interact with existing soil minerals and organic matter. This concentrated interaction zone produces humic substances at an accelerated rate compared to broadcast applications. The vermicompost provides not just nutrients but a complete soil food web including bacteria, fungi, protozoa, nematodes, and microarthropods that process organic matter through multiple digestive cycles. Each cycle transforms the organic matter into increasingly stable forms, eventually creating true humus compounds bound to soil minerals. For maximum effect, install new vermicompost trenches in different locations each season, gradually treating the entire growing area over several years. The areas with previous trench treatments will maintain elevated humus levels for years after installation. Creating your humus building system. The most effective approach combines elements from several of these methods in a comprehensive soil building system. Start with sheet mulching to quickly build organic matter. Incorporate charged biochar for long-term carbon sequestration. Implement cover crop rotations between production seasons. Maintain wood chip pathways between beds. Inoculate your system with native microorganisms, and strategically add vermicompost through the interface method. Remember that building true humus takes time. There's no instant solution. However, implementing these methods will create noticeable improvements within a single season while laying the groundwork for truly exceptional soil over years. The rich, dark soil filled with earthworms and teeming with microscopic life will produce plants with remarkable vigor, nutrition, and disease resistance. If you've found value in these humus building techniques, please subscribe to the Hydrohaven channel for more in-depth gardening insights and share this information with fellow soil enthusiasts. Together, we're not just growing better gardens, we're rebuilding the living foundation that sustains all terrestrial life. Your garden's transformation into a humus-rich ecosystem represents one of the most significant contributions you can make to both local and planetary health.